Hey, what's going on, guys? Let's do the integration for these two things right here. Let's start with this one. So here if you see that these two has sin x, so first thing I can do is I can take the sin x command and see what happens. So integral sin x, if I take sin x command, this is going to be 1 plus cot square x, and in the bottom we are going to have cosec square x dx, right? And 1 plus cot square x. So whenever we see something like that, it clicks in our mind, we can replace this one with something. So if you look at this equation, sin square x plus cos square x equal to 1, and here we are dealing with cot square x, right? So if we want to get this one, what we have to do here, if I divide this one by cos, it will become tan, it will become 1, so we don't need that. If I divide this one by sine, I will get a cot square. So sine square x, sine square x, sine square x. So this will give a relationship between cot square x and others. So here we will get 1 plus cot square x is equal to cosec square x. So I can replace this 1 plus cot square x with cosec square x. So that will make everything easier. So here we are going to get sin x cosec square x, in the bottom also cosec square x dx. Now we can cancel the cosec square x and cosec square x. We only left with sin x dx. So this is gonna give us. So if you integrate this one, that will give you minus cos x plus constant, and that is the final integration. So let's do this one right here, other side, and see what we get. So this is the definite integral, and it's going from 0 to a, and we have this function right here. So let's see, a represents the number. So the first thing I can do, I can do the u substitution right here, because since the derivative outside, if you do the derivative for x square, you will get x. So we can do the u substitution. So let's pick up u as a square minus x square, and if I take that one, I can find the du, that is going to be, since we know that a is a number, so if I find the derivative, this will become 0 automatically, right? So here we are going to have minus 2x, and that's going to be minus 2x dx. That's going to be the derivative, but here we can substitute the u. Within the square root, we can substitute the u, but if you see the outside, we have x dx left. But what we got is minus 2x dx, so let's try to bring this one into x dx pattern. So to do that, what I can do, I can bring the negative 2 to the other side, so that will make this one x dx. So this is going to be minus du by 2, that's going to be equal to x dx. Now we can write everything in terms of u. So let's write everything in terms of u, but before I do that, I have to find the new limits of integrals. So limits of integrals is here we have 0 to a. To find the new limits of integrals, all we have to do is simply substitute the 0 and a and see what value we get. So for 0, if you substitute 0 for x value, you will get a square. So that's going to be the bottom integral in the new limits of integral. And the top value, if you substitute a for the x square, you will get a square minus x square, that's going to be 0. So it's going to go from a square to 0. So that's going to be the new limits of integral. So let's write everything in terms of u. So the new limits of integral, this is a square to 0, and here we have x dx, that is going to be replaced with minus du by 2, but I can bring the minus 1 over 2 to the front. Since it's constant, I can bring it to the front. So this is going to be minus half in front, and the other side we are going to have this square root of, instead of a square minus x square, we can put the u. So here we are going to have the u, and we already seen that x dx is minus half du, minus half already taken, du is left, we can put it right here. Now it's easy to integrate, so let's do the integration. So minus half a square to 0, and u basically represent square root of u means u power half, right? Same thing, u power half du. So if you integrate this one, this is going to be u power half plus 1, that's going to be u power 3 by 2, right? So u power 3 by 2 divided by 3 by 2, then it's going from a square to 0, a square to 0. So let's see what we can cancel right here. 1 over 2, we can flip this one. 3 by 2, it is going to be 2 by 3, and u power 3 by 2 going from a square to 0. Here we can cancel the 2 and 2, and we are left with minus 1 over 3. Minus 1 over 3, so let's continue this one right here. So minus 1 over 3 u power 3 by 2 going from a square to 0. And let's substitute these values and see what we get. So if I substitute the 0 for u value, this will become 0. The whole thing will become 0. So this one is 0 minus, then we have a minus sign right here, minus 1 over 3. If I substitute a square for u value, let's see what we get. A square power 3 by 2, 2 cancels, and it's going to be a cube. And also this minus minus become plus, so this is going to be plus 1 over 3 a cube, and that is the final answer. I hope you guys liked this video. See you next time.